So now we are going to talk about electrical energy. So what I need you to do, if you haven't done so already, is get your note packet out and locate the N5 electrical energy page and prepare to take some notes. This one won't be very long. So the definition of electrical energy, a lot of times it's represented as EL on our energy bar charts, is the potential energy caused by the attraction and the repulsion of electrical charges. Remember the video that I showed you the other day? This was the Van de Graaff generator, and the guy had turned it on, and he had those tin pie plates on the top of it, and when he turned it on, the tin pie plates kept kind of flying off. So remember, electrical energy is the potential energy caused by the attraction and repulsion of electrical charges, and the Van de Graaff generator is a electron elevator which pulls electrons up to the top and makes it negatively charged. Now, so if we're going to predict the strength of electrical energy, there's 4 rules that you need to keep track of. The first rule says that opposite charges attract and like charges repel. And we've talked about that a couple of times already this unit, but it's just good to keep that in our mind. Number 2 is objects with stronger charges tend to have more electrical energy. We'll look at a couple of examples in a second, but just make sure that you remember that. Rule number 3 says closer like charges have more electrical energy. Again, something to think about. Rule number 4 says farther opposite charges have more electrical energy. So we're going to take a look at how these rules apply to different scenarios, and then you'll have some homework on it. So the first scenario is which pie plate, the one on the left or the one on the right, has more energy. And so in this particular case, we are looking at the one that has the more electrical energy is let's see, which one was it? Closer, is this particular pie plate right here. Now, the reasoning behind it, and this is going to be important that you can go back and do it, is the statement closer like charges have more electrical energy. Okay, so you have to be able to identify that. Now, in this example, we are asking ourselves which balloon has more energy, and we're going to take a look at the 2 balloons, and the balloon on the left, there's the cat again. The balloon on the left has 2 positive charges and 1 negative charge, and the balloon on the right has 3 positive charges and 1 negative charge. So in this case, this balloon is going to have more electrical energy. And we want to remember that the reasoning behind it is stronger. My goodness, that is my cat being very sassy. Is that stronger charges have more electrical energy. Okay. Now, that's example number 2. In example number 3, we're trying to decide which balloon has more energy. Now, one of the rules says that, so actually we're looking at these balloons. They both have 1 negative charge and they both have 3 positive charges, but one of the rules says that the further opposite charges have more electrical energy. So this balloon is going to have more electrical energy, and the reasoning again is the farther opposite charges have more electrical energy. Okay, so note that both of the balloons have more positive charge than negative charge. So that's why they're the farther opposite charges having more electrical energy. And then the last example that we're going to take a look at is where we're going to draw an energy bar chart for the pi plate as it moves up and away from the Van de Graaff generator, VDG. So at spot A, we would say that this particular pi plate has all electrical energy. And the system in this case is the pi plate. There's nothing really acting on the system, so we're not really putting in energy because we're talking just about the pi plate. Now, as it moves up and away, it's still going to have some electrical energy, but it's also going to be fighting against gravity, just like things are when they're up off the ground. And so now we're going to talk about that having some gravitational energy. And so this is spot B. So if you were to write an energy diagram for this, you would say, or an energy equation, you would say that we have electrical energy is equal to gravitational energy plus electrical energy. Now, the problem didn't really ask you to do that, but if you were asked to do that, that is something that you might have to do. Now, the last thing I want to talk to you about today is what your homework is for the evening. Your homework is to locate worksheet number 5, electrical energy. There are 3 questions on it, but there's 2 sides to this worksheet. The other thing that I want you to be aware of is each question has like an A, a B, and a C, and you have to complete all of them for homework. Good luck, and I hope you have a good day.